Hello friends, here is ZimaBlade, a compact single-board server created for those who want full server functionality in the simplest and most accessible format. This device is aimed at modern home scenarios, your own file storage, a media server, containers, smart home services, and experiments with self-hosted solutions. Everything that previously required either a full-fledged PC or complex setup. ZimaBlade is built around an energy-efficient x86 platform, supports full-fledged work with containers, and offers the proprietary ZimaOS operating system, which noticeably simplifies entry into the world of home servers. In this video, we will look at ZimaBlade from a practical perspective. I will show installing ZimaOS from scratch, connect an external hard drive and configure it as storage in the system, go through the basic interface and key features, and also install a few useful add-ons, a torrent client, and a container with Home Assistant. Let's figure out how convenient all this really is and whether ZimaBlade is suitable for the role of an out-of-the-box home server. And before we begin, as usual, I ask you to like this video. This will help other people who are interested in this topic find it. And subscribe to my channel if you haven't done so earlier. Before moving on to practice, let's take a quick look at the specifications of ZimaBlade. The device is produced in two versions, and in my case, it is the top model ZimaBlade 7700. It uses a quad-core Intel Atom E3950 processor with low power consumption, only about 6 watts, and at the same time fully passive cooling, no fans and no noise. Inside there is a SODIMM RAM slot with support for up to 16 GB of DDR3L, and 32 GB of built-in eMMC memory are provided for the system. For connecting drives, there are two SATA ports with a bandwidth of 6 gigabits per second. You can connect hard drives or SSDs directly without adapters. For networking, there is Gigabit Ethernet, one USB 3.0 for external devices, and also a PCIe connector that provides room for expansion and experiments. Separately, it is worth noting support for virtualization, ASNI hardware encryption, and hardware video decoding. All of this is important for server and media scenarios. ZimaBlade is powered via USB-C with power delivery support, so it does not need a separate bulky power supply. The device comes in packaging with a minimalist design, and ZimaBlade itself immediately attracts attention with its transparent case. Through it, you can clearly see the board, the connectors, and the overall layout. It looks more like a neat laboratory device than an ordinary consumer gadget. The case is fully passive, without any ventilation openings for active cooling, which immediately hints at silent operation. Overall, already at this stage it is clear that ZimaBlade is designed for stationary use somewhere on a shelf or next to a router, and not to be hidden under a desk. The bundle is as basic as possible, without any extra accessories. There is a USB-C cable to power the device, as well as a SATA cable for connecting a drive directly to ZimaBlade. There are no power adapters, drives, or additional modules in the box. It is assumed that the user already has everything necessary or selects it separately for their tasks. My bundle, which the link under the video points to in the official store, also includes SODIMM DDR3L RAM with a capacity of 16 GB. This is the maximum capacity supported by ZimaBlade, and it immediately provides headroom for further use, containers, additional services, and multitasking. The memory is supplied separately and is installed by the user, which fits well with the idea of flexible customization of the device for your tasks. The next item in the bundle is an adapter from mini DisplayPort to HDMI with support for 4K output at 60 Hz. It is needed for the initial connection of ZimaBlade to a monitor or TV at the stage of installing the system or basic setup. Such an accessory is not required for permanent operation, but it is necessary for the initial setup. A power supply unit is also included in the bundle. It is made in a format with removable plugs, which immediately simplifies use in different countries. The bundle includes 3 options: a European plug, a British version, and flat plugs that are used in the USA and a number of other regions. In my case, I need the European version, so there are no questions with the connection, just attach the right plug and use it. If we talk about the power supply specifications themselves, it is designed for an input voltage from 100 to 240 volts. On the output, it provides 12 volts at a current of up to 3 amps. a total of 36 watts, which should be enough both for the mini server itself and for the hard drives it powers. The next item in the bundle is a SATA Y cable. It is intended for connecting drives directly to ZimaBlade and allows you to work with two SATA devices at once. Such a cable is needed if you plan to use two drives as external storage, without additional adapters and converters. Also included in the bundle is a metal enclosure for installing one or two 3.5-inch hard drives. This is a convenient frame in which you can neatly install the drives and use them together with ZimaBlade as permanent storage. At the same time, ZimaBlade itself can be placed directly on top. The enclosure is designed for such placement and allows you to assemble a compact and neat setup. After we have sorted out the bundle, I want to give a small recommendation from myself. At the stage of initial setup of ZimaBlade, it is very useful to have a regular USB hub at hand. It is needed in order to connect a bootable flash drive and a keyboard at the same time. One USB port on the device is not enough for this. For permanent operation, such a hub is not needed, but at the stage of system installation and the first setup, it noticeably makes life easier and saves time. Now let's take a slightly closer look at ZimaBlade as a device. Externally, it is a compact server in a neat case, measuring about 11 by 8 by 2 centimeters, with a transparent top panel. Through it, you can clearly see the board and the layout. The case is designed for passive cooling, so ZimaBlade runs absolutely silently and is intended for 24/7 operation. If you look from the side, the passive cooling fins are clearly visible. Thanks to low power consumption and well-thought-out heat dissipation, the device does not require fans, which means no noise, dust, or maintenance. This is especially important if the server is located somewhere in a living room, next to a router or a desk. From the rear side, there are two SATA ports at once. This is a rarity for devices of this size. You can directly connect one or even two drives without USB adapters and external enclosures. This approach immediately makes ZimaBlade a convenient base for a NAS or local storage. Everything here is as server-like as possible. Minimum unnecessary stuff, maximum practical benefit. But the most interesting feature of ZimaBlade is on the other side, a full PCIe connector. And not all mini PCs and single-board computers can boast that. PCIe opens up possibilities for real expansion. Network cards, controllers, additional interfaces. All of this can be connected directly. It is the presence of PCIe that strongly distinguishes ZimaBlade from ordinary compact computers and makes it precisely a server platform, not just a small PC. As for the main interfaces, everything is in place here as well. There is Gigabit Ethernet for networking, USB 3.0 for peripherals, mini DisplayPort for connecting a monitor, and USB-C for power. Once again, I draw your attention. USB 3.0 is only one, and for the initial setup, a USB hub will be very useful. Disassembling ZimaBlade starts with removing the side cover. It is held by latches and comes off quite easily, without tools. The transparent top cover is a separate element. It is fastened with screws and does not come off just like that. On the top side of the motherboard, there is a SO-DIMM RAM slot, SATA connectors, the network controller, and all the surrounding circuitry. If you look from the side, you can see the processor itself through the gap. It is pressed directly against the case through a thermal pad, and the case here serves as a heatsink. That is why I did not disassemble the device further, so as not to damage the cooling system. After that, we install the RAM. A standard SO-DIMM DDR3L module is used, which is simply inserted into the slot, like in a laptop. There are no difficulties here. Everything is done literally in a couple of minutes. After installing the memory, the case is assembled back just as easily as it was disassembled. As a result, we get a compact, fully passive server with proper cooling, upgrade capability, and a feature rare for this form factor, a PCI connector. For storage, I decided not to buy anything new. I had an old, but fully working 3.5-inch hard drive with a capacity of 1 terabyte in reserve. That's what we will use. I connect the drive directly to ZimaBlade via the included SATA cable, using one of the two SATA connectors on the case. I will also need power. You can use the included cable and a suitable power supply with support for the PD protocol. From the accessories, an HDMI adapter, since I don't have a monitor with DisplayPort. But my bundle allows moving to a neater option, installing the drive into the rack. The rack is designed to install one or two 3.5-inch drives, and ZimaBlade is placed on top. In the end, we get a compact server, ZimaBlade on top, a 3.5-inch drive on the bottom, everything connected properly and without makeshift hacks. That's it for the hardware part and storage. Next, we move on to the most interesting part. I connect the monitor, network cable, and power. ZimaBlade turns on automatically. The device behaves the same way in case of a power failure. It turns on automatically after power is restored. A startup screen appears. At this moment, you can press Delete to enter the BIOS and check the basic settings before installing the system. This is the main BIOS screen from American Megatrends. Here you can see that the RAM has been detected correctly, 16 gigabytes, frequency 1333 MHz. The firmware version, the board model, and the manufacturer Icewhale are displayed. Everything looks normal, without errors and warnings. In the CPU settings section, we check the basic parameters. Support for a 64-bit architecture is present. Virtualization is enabled. This is important if you plan to use containers or virtual machines. Here are the integrated graphics settings. The integrated GPU is enabled and selected as the primary one. This is needed for correct image output during system installation. The amount of video memory is set automatically. There is no need to touch these parameters. In the boot section, the device order is specified. The BIOS sees bootable media and works correctly in UEFI mode. We will come back here a little later. ZimaOS was initially already installed, but the version turned out not to be the latest. Therefore, I decided to update to the current version at the time of recording the video and at the same time show the entire installation process. We use the official ZimaOS repository on GitHub. As usual, I will leave a link to it in the description under the video. In the releases section, all versions of ZimaOS are collected with a description of changes. There are both alpha builds for testing and stable releases. For installation, I choose the latest stable version, without experimental features. For a clean installation from a flash drive, you need an installer image for x86_64. That is what I download. To write the image, I use Balena Etcher, a simple and reliable option without unnecessary settings. I select the downloaded ZimaOS installer image, specify the flash drive, and start writing. After completion, Etcher automatically verifies the data, so the flash drive is immediately ready to boot. Next, we connect the flash drive to ZimaBlade and enter the BIOS. In the boot section, we select booting specifically in UEFI mode, the flash drive entry marked as UEFI. This is important because ZimaOS is installed and works correctly specifically via UEFI. After selecting the boot device, we save the changes and exit the BIOS. The server reboots and automatically starts from the flash drive. The ZimaOS installation process begins. After booting from the flash drive, we get into the text-based ZimaOS installer. Everything is as simple as possible here. Select Install ZimaOS and proceed to install the system. I deliberately choose the internal eMMC drive, not the external hard drive. This approach allows you to freely connect and disconnect external drives later without needing to reinstall the system. They will be used exclusively for data storage. The installer warns that the selected drive will be completely erased. This is a standard step. We confirm continuing the installation to the internal eMMC, the final confirmation before the installation starts. After this, the system begins copying files and partitioning the disk. The installation of ZimaOS onto the internal eMMC drive is in progress. The process takes only a few minutes and requires no intervention. The installation has completed successfully. Now you can remove the installation flash drive and reboot the device. After the reboot, we enter the BIOS again to check and, if necessary, adjust the boot order. In the list of devices, the installed UEFI partition of ZimaOS on eMMC has already appeared. As boot option number 1, select UEFI OS, MMC, the system installed on the internal eMMC. This is the final step. Now ZimaBlade will always boot from the internal drive, and external drives can be used as storage. After installation, the system boots for the first time. On the screen is the standard Linux startup process, kernel initialization, file system check, and startup of network services. After the boot completes, the ZimaOS start screen appears with basic information. It shows the device model, system version, kernel version, and the IP address at which the web interface will be available. Important: it is on this screen that the system prompts that to change the root user password, you need to press Alt plus F2 and run the password command. After pressing Alt plus F2, We get into the console interface and see the login prompt. By default, the root user is used and the password has not yet been set. Log in as the root user. On the first startup, the system lets you in without a password. This is normal and is needed for the initial setup. The final mandatory step of the initial setup is setting a password for the root user. Run the password command, enter a new password, and confirm it. This is already the ZimaOS web interface, not the image from the monitor connected to the board. After installing the system, the monitor and keyboard are no longer needed. From here on, all work is done from a desktop computer through a browser. We go to the IP address that the system displayed on the screen at the first boot and get to the start page of ZimaOS. Here we choose the interface language and accept the privacy policy. Creating a local user to work with ZimaOS. Specify a username and set a password that will be used to log into the web interface and manage the system. The system offers the main scenarios: disk management, files, remote access, and installing applications. I immediately go to Dashboard, as shown by the arrow on the screen, to open the main control panel. After entering the dashboard, the system immediately offers to install Zima Client. This is a proprietary client for convenient connection to the device, working with files and remote access. On this screen, ZimaOS explains that the client automatically chooses the optimal connection method and simplifies working with the server. On the next step, remote access capabilities are shown. Zima Client allows connecting to the device not only from the local network, but also from outside, without complex manual port forwarding settings. This step can simply be skipped further. Here the system shows the peer drop function, simple file sharing between devices on the same network. To continue setup, you need to press the Download Zima Client button, as shown by the arrow on the screen. I will install the client and show it a little later, but for now we continue with the basic system setup. This is what the system dashboard looks like by default. For now, let's go to the settings menu. To do that, click the gear icon in the top panel, as shown by the arrow. All the main system parameters are collected here: account, device, storage, network, and applications. Account section. Here the local administrator account created at the first system startup is displayed. In this section you can change the password, avatar, and also add additional users, if several people will use the server. General section, General System Settings. Here information about the device and the ZimaOS version is displayed, and the interface language, time zone, time format, and the dashboard appearance are configured. The device info window shows the main device characteristics: processor, amount of RAM, graphics, and serial number. Storage section is responsible for managing drives. Here the system offers to create storage and combine connected disks. For now, we leave this step unchanged. We will return to storage setup and connecting an external drive separately. In the network section, the network connection parameters are displayed. You can see the active Ethernet connection, as well as the remote access status. By default, the system is already ready to work on the local network, without additional setup. Apps section shows where application data, Docker images, and user information are stored. By default, all paths point to the internal storage of the device. We will also return to these settings later, after connecting and configuring the external drive. Let's return to the storage section. At the top you can see the current state of storage. It has not been configured yet. To start working with a new disk, click the Start button in the storage creation block, as shown by the arrow. The system offers two options: combined use, combining multiple disks using RAID, and single use, using the disk as a separate drive. In my case, there is only one disk, and it will be used separately, so I choose single use and proceed. ZimaOS detected the connected disk, but the system immediately shows the status format required. This is normal. The disk has partitioning and file systems that ZimaOS cannot use. To continue, the disk needs to be formatted. Before formatting, the system warns once again. All data on the disk will be completely deleted. Here the storage name is set. In my case, it is HDD storage. Check the confirmation box and click Format. After formatting, the disk appears in the list as ready to use. Now it needs to be enabled in the system. To do that, click the Enable button as shown by the arrow. The system reports that the connection was successful. The disk is activated and ready to work. You can go to the File Manager or return to Storage Settings. We return to the storage section and see the result. The external disk is displayed as HDD storage with an available capacity of 1 terabyte. The same is visible on the main dashboard. The storage capacity has been updated. The system is fully ready to work with the external disk. Meanwhile, Zima Client has been downloaded to the desktop computer. Let's install and launch it. It automatically finds ZimaBlade on the local network and shows its IP address. Make sure the correct device is selected and click the Connect button as shown by the arrow. After connecting, Zima Client offers to choose which ZimaOS folders to connect to the computer. Both the system partition ZimaOS HD and the external disk HDD storage are available here. You can connect both or only what you need. Select with checkboxes and proceed. In Windows, the disk is connected as a regular network drive. In the properties, you can see the real capacity, about 931 gigabytes, which fully corresponds to a 1 terabyte HDD taking the file system into account. This clearly confirms that the disk is mounted correctly and available to the system. Here the network drive ZimaOS HD is open. Inside are the system directories of ZimaOS, including Docker, configurations, logs, and service folders. It is better not to use this partition for storing user files. And this is the external disk HDD storage, connected via Zima Client. It is completely empty and ready for use. This is where you can put media, backups, and container data. We return to the main Zima Client screen. Here the connection status, the device IP address, and quick actions are displayed. You can go to the ZimaOS dashboard, open network folders, or configure additional features. Zima Client has a built-in backup function. You can choose a folder on the computer and specify exactly where on ZimaBlade to save backups. Before moving on to applications, let's set up the location for their storage. We go back to the settings menu. We are interested in the last item. This is where you configure where application data, Docker images, and the user database will be stored. By default, everything is located on the system drive ZimaOS HD, which does not suit me. We start by migrating the data of installed applications. Select the external drive HDD storage and click Next. There is enough free space on it, and it is ideal for these tasks. The system warns that during the migration, Docker services will be temporarily stopped. Confirm the action and click Start Migration. Since I don't have anything installed yet, everything went very quickly. The application data migration completed successfully. Now app data is physically located on the external drive, and the system drive is no longer burdened with unnecessary data. Next, we migrate the application images. Similarly, select HDD storage and confirm the migration. The last step is migrating the user database. This is where user data, documents, downloads, and media are stored. Also select HDD storage and confirm the action. Now all the main components, app data, app image, and user database, are stored on the external drive HDD storage. This is the correct and recommended configuration before installing applications. We go to the ZimaOS App Store. Here you can immediately see the main thing. There really are a lot of applications. At the time of recording the video, 372 applications are available in the catalog, and the list is constantly expanding. This is not just a showcase, but a full-fledged catalog of ready-made Docker applications. Here you can easily find Home Assistant for a smart home, Jellyfin and Plex for a media server, Transmission and Qubit Torrent for downloads, as well as Nextcloud for your own cloud. If you scroll down, you can see how wide the selection is. There are applications for media, networking, backups, monitoring, automation, working with AI, and just useful utilities. Essentially, almost everything that is usually deployed through Docker manually is available here in a couple of clicks. There are many community applications in the catalog, including network services, proxies, VPNs, monitoring, and management systems. This makes ZimaOS a convenient platform for both beginners and more advanced users. In addition to the ready-made catalog, there is also manual application installation. You can specify a Docker image, set a name, ports, volumes, environment variables, and network mode. Essentially, this is a simplified and visual interface for deploying any Docker containers without working in the console. To avoid overloading an already fairly large review, next I will show the installation and basic setup of a couple of the most popular applications. We start with Qubit Torrent, which is quite logical for a system with large disk storage. In front of us is the application page in the ZimaOS App Store. You can see the description, the downloader category, and memory requirements. To install, simply click the Install button. After installation, the system immediately shows a window with tips. Here the username is specified, admin, and the password is suggested to be obtained from the container logs. You can also immediately see the standard paths that the application uses for data, downloads, and media files. Through the application context menu, the main actions are available. Open the web interface, go to Settings, Restart, or Stop the container. For further configuration, select Settings. The QBitTorrent container parameters open. Here the Docker image used and its version are shown. The web interface port, as well as the mounted directories. In the upper right corner, there is quick access to the terminal and the container logs. In the Logs tab, the container startup log is displayed. This is exactly where the system shows the temporary administrator password for the first login to the QBitTorrent web interface. This is the start screen of the QBitTorrent web interface. Use the admin login and the password that was previously obtained from the container logs, then click Login. After logging in, the main QBitTorrent interface opens. On the left are status and category filters. At the top is the control panel. In the center is the downloads list, which is still empty. For the initial setup, open the Tools menu and select Options. This is where web access and authorization are configured. In the Web UI tab, set a permanent administrator password. This is a mandatory step to replace the temporary password issued at the first startup. Add a local torrent file via the Browse button. Pay attention to the save path. It points to a directory inside the container mounted to the system. The torrent has been added successfully and is already downloading. In the list, you can see progress, download speed, number of seeds, and time remaining. At the bottom of the interface, detailed information is displayed. Speed, amount of downloaded data, number of connections, and the file save path. The downloaded file appears in the network directory of the storage. This confirms that QBitTorrent works correctly with the disk, and the files are immediately accessible from the system. And of course, I cannot ignore Home Assistant, which is also available in the system's App Store. Let's install it. After installation, the Home Assistant icon appears on the main screen of the system. The application runs as a separate service and opens via the web interface. When launched, the familiar start screen that many people know is displayed. Here you can either create a new smart home system or restore the configuration from a backup. I will not describe all the installation steps. I have done this many times. Everything is the same here. At the final stage, Home Assistant automatically scans the local network and suggests found compatible devices. The picture here will be different for everyone. After completing the initial setup, the main dashboard opens. Here the added devices, groups, and smart home controls are displayed. In the About section, you can see that Home Assistant is installed in the Home Assistant container format. That is, only the core itself, the logic engine, automations, helper entities, templates, and integrations. There is no add-on section here. They are installed separately from the App Store. But within the scope of this video, this will not be covered. I think that for getting acquainted with the device, this information is more than enough. We looked at ZimaBlade itself, went through the package contents, installed ZimaOS, connected an external hard drive, set up storage, got familiar with the web interface, and practiced installing applications, a torrent client and Home Assistant. The advantages of ZimaBlade include a compact form factor and easy system installation, an updatable operating system with a convenient interface, ease of creating and configuring disk storage, a large number of available applications, and the simplicity of installing them. Among the drawbacks that can already be noted, some components, including required ones like RAM, need to be purchased and connected separately. This is still not a set-it-and-forget-it gadget. A basic understanding of networks and containers will be a big plus. That's all. I hope this video was interesting and useful for you. I would be grateful for your likes. They help promote the video on YouTube. If you are not subscribed to my channel yet, now is the time to do it right now. In the description under the video, you will find all the necessary links to stores where you can buy this device, as well as to my social networks, Telegram channels, and a group for discussing smart home questions. Join in, it will be interesting. Thank you for your attention. See you next time, and peace to everyone.